Oh, I'm sorry. In the previous video, I said that let's turn to the next page, but I accidentally stopped the video, and so it should be to the next video, namely this one. And so this is page 64. Example 2. This new integral from 0 to 1 of bt square b1 minus bt square dbt. So let's compute the expectation of the square of this new Stochastic integral. This time, the computation of this Stochastic integral is very, very lengthy and complicated. And so to compute the expectation of the square of this, even more tedious, we will use our theorem to find the expectation of this above integral. Square to find this. One, the integral from 0 to 1 of the expectation of the integrand square is bt to the power 4, b1 minus bt to the power 4 dt. And that equals to the integral from 0 to 1. Now these two, they're independent. And so we can compute the expectation bt to the power 4 and then times the expectation of the b1 minus bt to the power 4. And the expectation of bt to the power 4 is a 3t square. And the expectation of the second factor is 3 times 1 minus t to the power 4 dt. And you can easily compute this to be 3/10. On the other hand, the double integral part is the integral from 0 to 1 and the integral from 0 to t of the expectation of. Now this is the case with fx equals to 5x equals to x squared. And so f prime is 2x, so it's 2 times bt times b1 minus bt square times bs square times thrice of b1 minus bt, and then ds dt. And this you can do it. You do it. It's very easy. And so that equals to is 1/5. Okay, so let's go to the next to the next page. So it's 65. Therefore, we get the expectation of our new integral from 0 to 1 of bt squared times b1 minus bt squared dbt, our new stochastic integral, and then square equals to 3/10 plus 1/5. This is the isoisometry part, this is the double integral part, and that equals to 10. 3 plus 2 is 5, and so it's 1/2. And I should make a remark where I mentioned it already before. I mentioned before that the derivation of this integral is very lengthy and complicated, but nevertheless, if we have nothing nothing better to do, please try to find it out. So here, if you have nothing to do, please compute this new stochastic integral. Just for fun. Enjoy it. Okay, so that is all I want to say. about the generalization of Ito's isometry. Now I should mention that in this theorem, where is the theorem? Oh yeah, here. This in this theorem, page 62. For this theorem, our new stochastic integral is this. This is a very special class of the domain of our stochastic integral. You see, the integrand is this. It's a product of Ito part and counterpart. And this appears in the first step of our new stochastic integral. In step 2, you recall that we take the linear combination of finitely many terms of the product. And so for the general case, what is this formula? We don't have it yet. So, and moreover, this is a special class of adapted part, and this also a special case of the instantly independent part. So one question is, suppose we replace this by ft, just adapted, instead of this form. This f is of course not this f. And the second factor is phi t, instantly independent stochastic process. And of course this phi is not that phi. So if we replace the integrand by ft times phi t, then it's a different story. So in that case, what is this equality? We don't know yet. As I mentioned, it's in the Hui noise formulation, Hui noise theory formulation. We have this equality, but the equality involved Hui noise differentiation operator, and that is quite very much involved in the Hui noise distribution theory. So what I'm saying is Hui noise theory can give us some motivation and some hint as what kind of result we can expect in the new theory. So the new theory of stochastic integration is somewhat between Ito theory and Hui noise theory. Okay, so that is enough for this video, and next time we do section 5.6, multiple Wiener Ito integral. Okay, bye.